basically configuring your secure Kafka client can be complex, and actually it should be, we think it should be easy for engineers to do so, or it should be abstracted completely. They shouldn't even care about that. They shouldn't care about the plumbing, really focus on their domain logic. So if you try to deploy in a normal environment your Kafka Stream app for the first time, you need to take care of a few things. First of all, you need to figure out which infrastructure you're targeting. So potentially DNS records, what we call bootstrap servers in the Kafka world. You need to think about how my connection to that backend is encrypted, how do I authenticate, and how do I manage the access control, the permissions, what we call the ACLs. So really, that's a lot. And as we've seen in the last few years with Francesco, it did take a lot of time on our teams to basically figure that out, and it's very error prone, obviously. So we thought, can we make that simpler? And maybe introduce, the sidecar container pattern, where this common sidecar here, we would pre-build it and we would make it configurable so that any of our teams, any of our engineers, when they deploy their Pink application here, they don't need to care about the layer on top. So the connection is handled for them, and the configuration hopefully as well. Now we can see it's still in red. We can see the user at the top on the Kafka side is still in red. There's a question, okay, who created the user and the user credentials on Kafka? So still actually on my engineer's plate, and same with the certificates for encryption or authentication. So it's not perfect, but that brings us back to your question at the beginning, I believe, regarding service mesh. We'll see about that. Now we need to go a bit further. So we decided to try and deploy an operator. And we picked StreamZ, again, a CNCF project. And here we can see at the bottom our manifest. That's our YAML skeleton for developers to easily write a configuration and deploy their application. And we thought, why not bundling it together with the configuration of the required infrastructure? The idea behind that is when you deploy a service, really, the infrastructure which is required for that app should be deployed and should be ready when you push it. So we have a set of templated, we use Helm in this case, templated charts, which not only provide a simple way to deploy the application on one side, but also trigger the creation of the required infrastructure and the different resources in a specific domain, in our case, Kafka. So StreamZ can be deployed in many ways. We won't talk too much about that today, but here the example of the user operator is using the operator pattern in Kubernetes, and it can be deployed standalone. As we can see now, it's being triggered by a Kafka user. So we see an object of type Kafka user, and here I'm going to just introduce or mention the CRD, the concept of this custom resource definition. When you install the StreamZ user operator, you're going to install a CRD and this new type in your Kubernetes cluster of object for Kafka users. So as we understand here, our manifest basic YAML will push further the app and declare a new user. What's interesting here is that we can predefine things like naming convention of the user, which is going to be important later to allow easy permissioning and management of those streams. Now, when this object is being created, it will trigger the operator, which itself will now manage the generation of secrets and credentials for our application, which are passed directly mounted to our proxy. So really, at this point, our application or our engineer only focuses on the application, on the pink box in there. We can potentially go a bit further. Again, a CRD at the end of the day, it's custom, so you could create your own. And we thought, sorry. I just need to mention one thing before I go too fast. You might ask, there are different types of resources in Kafka. You need to care about the users and you need to care about the topics. So we talked about the topics at the beginning of the talk. Managing the topics is also, well, you know, part of the game here. You need this topic to be existing on your backend. You need to be configured. You need the user to have access to it, and you need to manage those permissions. So same idea, same diagram, based on the manifest, one PR to our well, GitOps pipeline, and this will push the service, but also the topic and the permission, meaning that actually when your service or when your pod starts, it already has everything it needs. And here we can see the diagram. So we can see this new CRD also installed by the Streams operator for the Kafka topic. And we can define a few configurations in there. You can define, there's the concept of retention in the topic. For how long do you keep the data in this log of append only, you know, log of messages? So that's something you can configure. There's the replication factor. Kafka by nature, you know, you want it to be HA, highly available, so, and replicated. So those are things you want to configure, and you might want to even enforce and set a template for all of our applications to be deployed using the same type of topics. That will be useful for Kafka streams, but that also, you know, just for actually managing Kafka itself and making sure that nobody is creating an app where their topic is using replication factor 1, and potentially when you have an operation in production replacing some machines, you're going to actually have an offline partition. So that's one thing we've done. Now, as I said, we can go a bit further. A CRD is just something you can also create yourself. And the team had this idea to basically define a wrapper custom resource that we would call an event stream, which predefines some of those values. So the retention, the replication factor, the number of partition in a topic. And as we can see in the diagram here, we deployed our application in pink, and we can see it seems to be consuming from a topic, and we have another service in our architecture which is producing events in there. All of that can be written somewhere in the manifest and can be managed in the Kubernetes state in a CRD. And that will help us in the future potentially to manage better this, you know, potentially this set of applications. We're going to deploy a lot of them. It's going to become really, really complex to manage in one environment. And if we deploy it to several, it's really a mess.